All right, moving on to 2.2 today. As I told you yesterday, everything that we do in chapter 2 is doing different things with functions. And so yesterday was just really trying to identify the different types of functions, getting introduced to the piecewise function. Today, what we're going to look at is doing some different things with some of those functions. And we won't see absolutely every single one, but we're going to see a lot of different types of functions today, and we're going to do some different things with them. Calculator is going to be a pretty big tool today, so if you get your calculator out, we'll use your calculator a little bit today to kind of help us out as well. Okay, so to begin with, we talked about this a little bit in chapter 1. When we talk about the zero of a function. The only one that we did it with in chapter 1 was a linear function. And I might give you a function that looks like this. F of x equals 2x minus 4. And what I'm going to tell you here is that the zero is the same thing as the x-intercept. So I can do it off my graph, or I can do it algebraically as well. If I'm finding a zero of a function, if I was going to do it algebraically, I could just set 2x minus 4 equal to 0, and I could solve for x. And I get x equals 2. If I were to do it off of my calculator or graphing it, my y-intercept is negative 4, but we're looking for the x-intercept, not the y-intercept. My slope is 2, so we're going to go up to right 1. And when I graph it, 2, 0 is my x-intercept. Okay? We always write the x-intercept as an ordered pair, but it's also x equals 2. Okay? So where it crosses the x-axis is what we call the 0. It's the x-intercept and it's the 0. And so we did one like that in chapter 1, and so that one's pretty familiar to us. But we're going to look at ones that are not just linear today. We're going to look at what happens if I have like a quadratic equation, for instance. And we haven't talked about how to solve a quadratic by hand yet. So really the best and only way that we're going to do it is to graph it. So here we have a quadratic function based on what we talked about yesterday and what we've seen before. Because it has an exponent of 2, we know this is going to be a parabola, right? And the fact that it's a parabola, we know it's a U-shape, so we're going to put it into our graph. Okay, so if I said, what are the zeros? I would say x equals negative 1, positive 2. If I called them the x-intercepts, it would be negative 1, 0, and 2, 0. Okay, two numbers are the same, negative 1 and 2, but just express them a little bit differently based on the what we're looking for. Okay, let's do a third one here. If we graph this one, still know it's a quadratic equation, okay? And the fact that it's a quadratic, we know it's a parabola. No zeros, which means there's also no x-intercept. So using the calculator is the best and quickest way to get there for those. Later in the semester, we'll talk about how to solve quadratics, and we'll do more work with quadratics. But for right now, that's going to be our best method. Okay, another one that we're going to talk about today. increasing, decreasing, and constant functions. And so what we're going to look at on some graphs like this is where is it increasing, where is it decreasing, and then where is it constant. And you'll have some graphs that may have all three. You'll have some graphs that only have 2 out of the 3, and I'll show you some different examples here. Increasing means the graph is going up. Okay, maybe it's going up as a line, maybe it's going curving up, but it's going up as it moves to the right. Decreasing means it's going down as it moves to the right. Constant means it's going to be flat as it goes across from left to right. So I'm going to show you an example of each one here. Eventually today we'll talk about how to find this max point, but on some of the graphs that we're going to do today, it's going to go ahead and give me that point. That's where it reaches its high point is at -1, 5. And so I want to find out where is this graph increasing versus decreasing. Well, over here on the left-hand side, if I start on the far left, just like we do any other thing, we're going to read it from left to right. We start here, my graph is going up. Once it reaches this high point, now it starts to drop or go down, right? And so on the left-hand side of this graph, it's increasing. On the right-hand side of the graph, it's decreasing. And the way that we write our answer here is very similar to what we do with domain. It starts all the way to the left, right? So all the way to the left would be -infinity. And it's going to keep increasing as I move to the left. And the only thing that we're focused on here is the x value. The x value is our key, okay? Because we're moving across the graph, across the x-axis. So it's going to keep increasing until it gets to -1, because that's my x value. So we don't even use the 5. Okay, 5 is just where it reaches its high point, and we'll talk about what the 5 means later on today. Okay, and then at -1, it changes direction, right? So then now it starts to drop. And we would say it's going to drop from -1 to forever. It's going to keep going down as it moves to the right. And that would be our increasing and decreasing. This one does not have a constant function. There's no place where the graph stays the same. We do not have to worry about brackets and parentheses on this. That's the one big difference between this and domain. Domain, because at -1, it's neither increasing or decreasing. So we're not including -1. -1 is just where it changes its direction. And so don't worry about brackets when we do this. Okay, if I look at another one, just a little bit different here. Over here, it starts to decrease, right? So on the left-hand side, this time it's decreasing because the graph is flip-flopped. It's a V instead of a U, but still same idea. And then on the right-hand side, it's increasing, okay? So as we look at increasing and decreasing once again, I always like to go left to right. Well, the first part of the graph from -infinity all the way across until we get to 2, this graph is going to decrease. So from -infinity to 2, the graph is dropping or decreasing, going down. All D's, right? Kind of an easy way to remember it. Decreasing, dropping, going down, descent, all D words. Increase, it starts at 2, and the graph is going to go up as it goes to the right forever. Okay, so 2 to infinity, the graph is increasing. At 2, it starts to go up, and it'll keep going up for forever. Okay, a constant function is going to be a graph that looks like that. Okay? This graph never increases and never decreases. It just stays flat the entire time. And so we would say that this graph is constant from negative infinity to positive infinity. It stays constant forever. Okay, I'm going to show you an example of one here that's going to have all three parts to it. And it's going to be a piecewise function like we kind of saw yesterday, where you're going to have different pieces or different parts to the graph. I'm going to put the points on here first that I want to use. Okay, so here's what my graph is going to look like. And yesterday I told you, like, when we do a piecewise function, I'm not going to give you any, like, curves like this, but if they just give you the graph like this, you might see some that have some curves. The first thing that I like to do on this, as I go from left to right, is I just like to write whether it's increasing, decreasing, or constant for each individual part, okay? We basically have 1, 2, 3, 4 parts here, right? Each one of those parts is doing something different based on what it's doing. So what is the graph doing right here? Decreasing, okay? So I'm just going to put a D by it. When I get to -2, now what happens? It's constant, okay? And then when it gets over to 3, it's going to increase, it's going to grow. And then at 5, it's going to decrease again. And by putting those letters there, do you have to do that? Not really, but I think it helps to just identify what's going on at that particular instance. And when I write these out, I write out I, D, and C. You can write the whole word if you want to, but increasing, decreasing, and constant. And however you want to do it. I just kind of work left to right. So from negative infinity to -2, because remember we're only using the x value, it's going to decrease. And then it's going to be constant from -2 all the way over to +3. At 3, it's going to increase till it gets over to 5. At 5, it's going to decrease again to infinity. You don't necessarily have to put the U symbol in here either. We're just writing each interval that it's increasing, decreasing, or constant. Okay? So we had 4 intervals that we had to account for. So you should have 4 different parts to your notation here. Okay? Everybody all right with those? Any questions on any of that? Okay. The last couple of things that we're going to do here, we're going to look at a couple of different examples. And we're going to throw in another part or piece that we're going to find from a function. Okay, and as I told you, like on the last couple that we did, it gave me like the minimum or the maximum value. This time we're going to have to find what that minimum or maximum value is. And the reason we call it the relative min or max is because if I were to give you a function, let's say I look at like my snake-like function right here, okay? Well, this one's going to go down forever and it's going to go up for forever. So it doesn't really have a minimum and a maximum because it goes in both directions forever. But when we find the relative min or max, it's going to be where does it reach a high point at some point in the graph. And what you'll find out is on some of these, it'll only have a max or it'll only have a min. You will have some that have both. Okay? And so we'll talk about how to find each one of those. Here's another place where your calculator is going to come in really helpful as well. So I'm going to give you a function. All those functions that I gave you yesterday, we're going to see different variations of each of those functions as we continue on through chapter 2. So you're going to see quadratics, you're going to see absolute value. You're going to see some a lot more than others. Some of those we won't hardly see at all. But quadratic and absolute value and cubic are probably the three most common. And linear probably as well. Although we used linear a lot in chapter 1, more so than we do in chapter 2. So what we're going to start with here is we're going to graph this. And you can totally use your calculator to graph this. So let's put this into our calculator. But first of all, we're going to go up 4. And I'm not going to get real specific here. But 0, 4 is a maximum value where it reaches its high point. There is no low point that it ever reaches. So we would say that this has a relative max, and usually we call that relative max the 0.04, but the y value of 4 is my maximum value. So this is 4 is where it reaches its high point. So the y value is the maximum value, and it reaches that at x equals 0. Okay, so it's just a different way of rewriting the ordered pair. 0, 4 is the actual point where it reaches it. But if it said what is the maximum value of this, 4 would be the actual maximum value, because that's 4 is where it reaches its high point. Okay, so all we're doing is taking the ordered pair and just writing it a little different. We could do increasing and decreasing on this one as well. If I did increasing and decreasing on this one, you're going to have some that's going to ask you to do all of these things. So that's why I mentioned that here. It's increasing from negative infinity all the way over to 0, and it's decreasing from 0 to infinity. Over here it's increasing, over here it's decreasing. Okay, so that one's a parabola, and we found a relative max. Let's do an absolute value function. Okay, putting this into the calculator. I think there was a few times in chapter 1 where we talked about putting this into the calculator. Depending on the type of calculator that you have. If you have a TI, you're going to do y equals, you're going to do math, you're going to go to num, and it's then ABS. So it's kind of hidden. It's not just right out there to put that absolute value symbol in. Depending on how old your calculator is, if you have a newer TI calculator, it actually will put the vertical bars in the y equals for you. Some of the older calculators still just use the letters ABS for absolute value. The older calculators didn't put the actual vertical bars in there. So what you would have to do here is you'd have to do ABS, parenthesis, x plus 3, close it off, and then put minus 5 after the parenthesis. So if you have an older calculator, you would have to do that. Casio's, you just have to go into the function. Anybody need help finding absolute value? You guys know where it's at? Okay, but yeah, make sure you go over all this first. And then, I'll show you. Yeah. Yep. And sometimes we get real specific with the graphs. Today, I'm not getting real specific with the graphs, other than finding that minimum and maximum. That's the point that we're really focused on for today. So each day is going to be kind of different of what our main focus is. So you got to find that minimum or maximum. So if I'm going to go to my calculate feature. We did it for 0 earlier, and now we can do it for maximum or minimum. This is a minimum value. So you're going to go to calculate, you're going to go to minimum, you're going to do left bound, hit enter, you're going to go over to right bound, hit enter, and then hit enter again when it says guess, and it should give you -3, -5 as your order pair.
Wait, you click minimum or not?
This time it would be minimum because it's at the bottom.
How come mine's like -2.9999?
Yeah, okay, so that's a good question. Sometimes, so what your calculator's trying to do is it's trying to approximate it as close as it possibly can to what they think that value is. So if I, depending on where I put my blinking cursor over here,
Well, mine says -3.0001.
yeah, so that would be just the opposite of Danica. She has like -2.9999999.
But then my 4 is -4.99.
Yeah, right. So it's just, if you see something that has like 0.999999 like that, it's just that. It's just going to round up. Or if you see a bunch of zeros, same thing.
But it's zeros don't round up. No, it's, yeah.
Right, right. Okay, is everybody able to get that on their calculator? So the way that I would write this, I'm not going to do increasing and decreasing here. My minimum here, the ordered pair is -3, -5, but the way that the book is going to write it is they're going to say the minimum happens at y equals -5 when x equals -3. They don't really use the at symbol. I think they actually write at, but I like using the at symbol at x equals -3. Okay, all right, one more question. Okay, we're going to graph this one. Okay, and what I'll tell you about this one is going to kind of look, it's going to be a cubic graph. And we know it's a cubic graph because our highest exponent is 3. It's one of the other functions that we talked about yesterday. So when I see cubic, I should know it's going to make a snake-like graph. The only difference is this one, it goes the opposite direction. So this one has both. This one has a minimum and a maximum. So we've seen some that have just a minimum, just a maximum, and this one actually has both. So if you see a graph like this, we could identify both relative min and max. So we gotta, and it doesn't really matter which one you do first. You would go to your minimum under your calculate feature. So we would say the minimum is -6 at x equals 0. Okay, the maximum is not a nice whole number. You get like 1.3, -4.8, and I don't know if I rounded that or not. I don't think it's an exact answer, if I remember right. Is it exact or is it rounded? Rounded, okay. But I just rounded it to the nearest tenth, which is perfectly fine, okay? And a lot of times either the 10th or the 100th is typically what we'll round. And so here I would say the maximum value is y equals -4.8 at x equals 1.3. And I won't go through it here. But if I wanted to do the increasing decreasing function here, it decreases here. Always start furthest to the left. It decreases, and then it increases, and then it drops back down. Remember, we're only using the x values. So I would say negative infinity to 0. A lot of times people want to use the -6 because that's where it reaches its low point at. But x equals 0 is the x value. And then it's going to go from 0 over to 1.3 to increase, and then 1.3 to infinity. It would decrease again. Okay, so a little bit different on writing the increasing and decreasing function. Okay, I think that's all we got.